So we're going to graph a linear equation, but in terms of an application. So the following equation describes the pressure in pounds per square inch for a submerged body at a depth of d feet. So again, it doesn't really look like it is necessarily a linear equation, but if you think about the p as the y and the d as the x, then you can see that you can write it in a very similar linear equation, that y is equal to 0.52x plus 14.7. So even though it's not what we usually have been used to seeing, it's more of an application sense where it's using real numerical values associated with it. So A is asking us to use this equation to construct a graph of this relationship for the following basically constraints. So D is between 0 and 80. Be sure to choose values which are reasonable and useful. So in the past, we've looked at x and we've said, okay, let's choose 0 and let's choose some negative values and positive values. But notice that in this case, there is no negative value. So it's impossible to have a depth of a negative value in this case. So it says from 0 to 80. So we need to choose 5 points, but more appropriate to what we're actually dealing with. So I like to use my endpoints. So I'm definitely going to use 0. I'm definitely going to use 80. And then it's really about deciding what other points you want to put in between there. So I'm going to go up by 20s. So I'm going to create a table of values for D, and then I'm going to substitute that in to find my values for P. So D is like my X value that I'm going to be using. So I'm going to choose 0 as my lowest value, and I'm going to go up by 20. So I'm going to choose 20, 40, 60, and 80. And I can't really go beyond that because my constraints are 0 and 80. So I'm going to make sure that those two are both in there, and then I can substitute into my formula. So 0.52 times depth plus 14.7. So for each of our D values, we're going to substitute into this equation. So 0.52 times 0 plus 14.7 will give me 14.7. 0.52 times 20 plus 14.7 gives me 25.1. 0.52 times 40 plus 14.7 gives me 35.5. 0.52 times 60 plus 14.7 gives me 45.9. And finally 80, substitute into my formula, I end up getting 56.3. So now these are my ordered pairs. This is D is like my X value, and P is like my Y value. So I want to actually graph these ordered pairs on my graph. Notice we don't have any negatives, so I am actually going to make the bottom value my D. So I have no negative values. So I'll just make my line down here, my D axis, and I will make my line along here my pressure, my pounds per square inch. So we basically need to come up with our scale. So that's my D along the bottom. This is my P value in pounds per square inch on the top here. And my depth was in feet. And I can graph my ordered pairs. So D, I'm going to make 0, start here, and then maybe I'll go up by, I have 5 points along here, so maybe we'll go 20, 40, 60, 80. And then along the top, I'm going from 14 to 56, so maybe we'll go up by 5. So 10, 20, 30, 40, 50, 60. And then we can graph my ordered pair. So 0 and 14.7. It's going to be in here somewhere. Then we have 20 and 25.1 in that area somewhere. 40. Oops. 40 and 35.5. In there somewhere, 60 is 45.9. And then 80 is 56.3. So again, you see we're creating this linear model between my values. So this line I'm graphing to be P is equal to 0.52 times my depth plus 14.7. So not super accurate that I'm not using a ruler or anything like that, but at least it's giving me a graphical representation of my model that I'm looking at. So I have the relationship between depth and pressure. Next part of the question is asking us to make predictions on that. So B is asking me to use the graph to make to predict the pressure at a depth of 45 feet. So if we actually look at 45 feet, that's going to be, that'll be 50, so 45 is right here. So at 45 feet, our pressure, I'm predicting that to be approximately, I don't know, maybe we'll go 39-ish. We're pretty close to the 40 line, so approximately equal to 39 psi. And then C is asking me what will the pressure be at 45 psi. So 45 is up here somewhere. So if we find that value on my line and we drop it down, so here is 40, 50's in here, 55. So again, we're pretty close up there, so maybe I'm going to go 58-ish. So again, using a graphical model tends to give us a little bit of sort of prediction, just sort of a guesstimate about where our other values could potentially be based on the model that we created.